but take a closer look at its surface and you'll find many interesting puzzles about its past which are just waiting to be solved. The LRO, or the Lunar Reconnaissance Orbiter, has been scanning the surface of the moon since 2009, taking super high resolution shots of its surface from various angles, giving us a view of the entire moon like never before. In the last episode of this series, we looked at the mountains on the moon, and today we will look at some of the most interesting craters found on its surface. I'm Alex McColgan and you're watching Astrum, and together we will explore the surface of the moon and give you a view and understanding of our close neighbour that perhaps you've never had before. Because of the many surveying missions to the moon over the years, the entire moon has been mapped out, and you can view all the data obtained in a program called QuickMap, which I will post a link to in the description in case you want to check it out for yourself. Zooming out as far as we can go, on the far side of the moon we can find one of the biggest impact craters in the solar system, the Aitken Basin at 2,500 kilometers across, which is interestingly where the Chang'e 4 Chinese mission landed in January of this year. The LRO was even able to image the rover from space. But without the rover as a size guide, what you may immediately find unusual about the lunar surface is the complete inability to judge distances and scales for the images you are looking at. This is due to the lack of an atmosphere, the haze of which helps us judge distance on Earth, and things we are used to like trees and buildings, which help us judge scale. So I will always try and include some visuals to help you see how big something is in this video. As you can see, the surface of the moon is littered with craters. It doesn't matter where you are on the moon, there will be craters of various sizes. This implies that the surface is old and hasn't been renewed by lava eruptions from the mantle anytime recently, the most recent eruption thought to have happened 1.2 billion years ago. There are an estimated 300,000 impact craters over 1 kilometer across on the surface of the moon facing us, and millions more smaller than that, like the ones you are currently looking at. The moon can have such small craters because it has no atmosphere, meaning every meteorite heading for the moon will hit its surface. On Earth, most meteors burn up in the atmosphere. Just imagine how many shooting stars there are each night. Were it not for Earth's atmosphere, every one of them would impact our surface too. What's interesting about each crater you see here is that you can roughly estimate how old a crater is by how eroded it is. Craters which appear very smooth are much older than craters with lighter substances surrounding them, with sharp and defined edges. The bright patches haven't had so long to have a weathering effect happen on them. But weathering on the moon? How can that be? Well, this weathering is not caused by water or air, but rather by tiny micrometeor impacts and intense radiation from the sun, which dull the thin outer layer of the moon. If we speed along to the end of this image, we can see a relatively fresh crater only a few hundred meters across. Using LRO's narrow angle camera, we can see a close-up view of the effects of such an impact on the lunar surface. These linear patterns are the effects of the ejecta from the impact. Finer dust would have been blown across the surface with some force. Larger boulders not quite making it as far, although leaving a trail from where they rolled away from the impact. The crater itself isn't super clear in this image due to the time in the lunar day this was taken, the sun close to the horizon, casting long shadows across the surface, although you can still see fresh exposed material along the crater wall. Comparing this to an old crater, here you can see a much smoother and darker looking crater, although still brighter than the heavily weathered surface in the surrounding area. What I like about this image though, is that zooming in, you can see some ejecta that landed from another impact off the image. Here's a boulder that landed on the crater wall and then rolled halfway down. The only thing with these top-down perspectives is that you don't get a great concept of depth in the image. How shallow or deep can craters get? Luckily, the LRO doesn't just scan the surface, but can take more oblique shots of the moon too, which can definitely help us appreciate depth. Look at this fantastic image. The crater is around 21 kilometers across, and it has some fascinating details all around it. Again, we can see the trails left by huge boulders rolling down the slopes, and very bright walls implying it is a young crater, yet darker material at the base. The contrasts are really quite vivid, and it almost looks like some parts could have been liquid at some point. The impact would have initially melted the rock into lava, which flowed to the bottom, collecting in pools which have since solidified. The impactor was likely 2 kilometers in diameter and hit the moon 10 times faster than the speed of a bullet. That would have been some collision indeed. Another great image I have to show you is this. A crater 10 kilometers across. What's special about this one is its interestingly raised rim. This is another example of rock melting from the impact, but rather, this time, slopping beyond the rim and flowing down before solidifying again. If we look closely around the crater, you can also see ejecta scattered across the surface, disturbing the ground and leaving brighter patches exposed. See? Once you know what you are looking at, even the moon becomes very interesting. But these have been very pristine craters. What if a meteor lands somewhere a little less conventional? Here is a crater within a crater. The impactor hit the wall of the larger crater, meaning it has quite an unusual shape. Although, from a top-down perspective, it still looks quite circular. Just as a side note, this image is a true color image of the moon. Most other images of the moon are taken in black and white to save bandwidth. Astronomers prefer resolution over color, although the lowest resolution camera on the LRO is capable of color, and this is an example of it. But certain craters can be unconventional in other ways too. There's a little understood phenomena on the moon that scientists have so far struggled to explain, and that is coal patches found on the moon after the sun goes down. So far, we have really only focused on the cameras equipped on the LRO, but it has a host of other instruments on board, including the Diviner Lunar Radiometer Experiment, which has mapped the moon's surface temperatures. There are 2,000 points on the moon that cool down more than the surrounding areas when the sun goes down. When the sun rises on the spots again, they normalize their temperature and quickly blend in with the background. The only thing these spots seem to have in common? They are always found around young craters, no smaller than 50 meters and no bigger than 2.3 kilometers. But the spots themselves are much larger than the craters. Here is a heat map of the crater I was just showing you. White is the hottest parts of the image, blue is the coolest. As you can see, a large cool region surrounds the young crater. There is an ongoing investigation to find out the cause. What do you think it could be? There really were so many more images I could have shown you today, but I'll have to save them for next time. I just wanted to leave you with one final image that I found breathtaking. This crater, found near the south pole of the moon, is almost always in shadow. The sun never rises high above the horizon here, meaning only the peaks of the crater stick out enough to be enveloped in light. What you are left with is a stunning contrast, almost like the yin and yang symbol. This is certainly my new desktop background image. But this region isn't just an eerily beautiful place, but it is actually one of the candidates for the future Artemis mission to the moon. The lunar South Pole is of particular importance to future human missions, as there is thought to be millions of tons of water ice to be found in this region, at the bottom of craters like this, forever protected from the sun's rays. If there is to be a future colony on the moon, this is roughly where it would be located. So there you have it, a sample of some of the most interesting craters on the moon. Enjoyed learning about our moon today? As you can see, learning about science, or maths for that matter, doesn't have to be dull as long as it's done in a thought-provoking and intriguing way. That's why I'm a big fan of Brilliant.